All right, y'all. So 8.2 is going to deal with graphing polynomial functions. Now, you're not actually going to have to graph these. You're just going to have to pick out pictures. So they'll probably give you like 4 pictures and you pick out that graph, okay? But first, we're going to look at how to find the maximum number of real zeros, the maximum number of x-intercepts, and the maximum number of turning points. So recall. So for this section, you want to recall how to find the degree of a polynomial. So remember, the degree of a polynomial is equal to the highest exponent of the polynomial. All right, so you got to remember what degree is, because on these steps, the way that I find these max zeros, max intercepts, and maximum turning points is using that degree. So here we go. So the maximum real zeros. So this is the maximum number of zeros it could have that are real. Now, it don't necessarily have to have this many zeros, but this would be the max. Because sometimes they can have what we call imaginary zeros. So the maximum number of real zeros is equal to the degree of the polynomial. So if you got a degree 5, that means the maximum real zeros would be 5. The maximum number of x-intercepts well, if you remember, x-intercepts, the x value of the x-intercept is equal to the 0. So if the maximum real zeros is equal to the degree, then the maximum x-intercept is also equal to the degree of the polynomial. All right, y'all, then we look at what we call the maximum turning points. So if you remember when we had x squared graphs, they made parabolas that looked like a U. And those went from either decreasing to increasing, or if they were flipped upside down, went to increasing to decreasing. But notice, that was an x squared graph, and it had one turning point. So the maximum number of turning points they could have is going to be equal to the degree minus 1. So real zeros equal to degree. X-intercepts equal to degree. Turning points equal to degree minus 1. So y'all, that's the information you got to know for the first 3 questions in the homework for 8.2. Okay, so for example, we're going to find the maximum number of real zeros maximum number of x-intercepts and maximum number of turning points. Okay, so for my number one, y'all, I'm going to have f of x equals x to the sixth minus x to the third plus 4. So I need to find my max zeros, max x-intercepts, and then my max turning points. So all we got to know on this problem is what is the degree? And y'all, let me see. My degree, the highest exponent, is a 6. So there you go. Chat pulled in a little slow. So since my degree is 6, what's my max zeros? All right, so I'm gonna go with 6. Because remember, the max zeros is equal to the degree. The max intercepts, well, intercepts are the same as zeros, basically. So that's also going to be 6. But remember, the max turning points we just said was equal to the degree minus 1. So for this problem, the maximum turning points would be 5. And y'all, that's all you're doing on this. Look at that degree, and then bam, bam, bam. 2 of them are equal to the degree. Turning points is the degree minus 1. All right, y'all, so here's a bigger one. They got an x to the 12 minus 4x to the 4th plus a 9x minus 5. So y'all find me the max zeros, maximum x-intercepts, and then the maximum turning points. So what do y'all think would be my maximum zeros? All right, good job. It's definitely going to be 12. So how about the maximum x-intercepts? So that's going to be 12, because y'all, that degree is 12 on that. And then how about my maximum turning points? And there you go. So good job on that one. So they're going to try to trick you up on one of these. So here we go. F of x equals negative 9x minus x to the 6th. All right, so what y'all got on that? How many would be my maximum zeros? Oh, good job, 6. So you caught that, they had that out of order. Good job. Well, that means my maximum x-intercepts. All right, so that's a 6. And then how about finally, oh, you done got it. That'd be 5 on the maximum turning points. Now, for these first 3, find that degree. And then remember what we said up here. Equal to the degree, equal to the degree, turning points, degree minus 1. All right, so for what we got coming up, we want to go back to the chart we made last week. So I made a chart that said the degree could be even or odd. And then we looked at the lead coefficient. And that could be positive or negative. So remember, that gave me 4 different sketches. So the even, both sides went up. If it was even with a negative lead coefficient, both sides went down. Odd and positive went sort of uphill, left to right. And then odd degree with a negative lead coefficient went downhill, left to right. So you want to remember this picture for the problems we got coming up, okay? Because you're going to have to guess A, B, C, or D, which picture matches the polynomial. So we're going to do them on the math lab. So let me pull that screen up. All right, so y'all should be seeing my number 4 is where these start at. I'm trying to make my graphs just a little bigger. So y'all, they got a f of x equals 1/3 x squared minus 1. So my question would be, would that be A, B, C, or D? So remember, you got an even degree, which is 2. The 1/3 is positive. So when you're an even degree, positive lead coefficient, would your picture look like A, B, C, or D? All right, y'all, so let's see. Let me show you my chart again. So this was an even degree, positive lead coefficient. So notice we got an even degree, positive lead coefficient. Looks like both ends should go up. And if you look at these graphs they gave us, only one of these graphs has both ends going up, and that would be B, okay? All right, so let's try the next one with y'all. All right, so I'll make these a little bigger. So the first one's going downhill left to right. The second one has both ends going down. The third one is going uphill left to right. Your function is f of x equals x to the 5th minus x to the 4th plus x squared plus 10. A, B, or C. So I got a C, so let's see. We got an odd lead coefficient, that is 5. There's a 1 in front of it, that's positive. So that'll go uphill left to right, so good job. So you pick C and then you move on. So notice these graphs have the basic shapes. Now notice this one. I got an A, B, and C. So I'm gonna show you a trick on this one. That's the x to the 4th. So that's an even exponent, and it's got a 1 in front. So that'd be a positive 1. So it's even and positive. So both ends are going to go uphill. But y'all look at that. A goes uphill on both sides, and C goes uphill on both sides. So what we got to do, you see that negative 16 at the end? That's what we call the y-intercept. So we need to see which one of these looks like it's going through negative 16 on that y-axis. Now they're telling you here, all the graphs are going, that y scale means that the y values for each notch are going by 10. So the first one's barely on it, but look at this last one here. I'm going to zoom it up a little bit more. This last one looks like it's in between a -10 and a -20. So on that one, I would choose C. So in the case that they give you two pictures that are similar, look at those y-intercepts. See, the first one's going right on the line, so that'd be right at -10. So we wanted C because that one looks like it's in between the -10 notch and the -20. So on some of these, you might have to play with the y-intercept, okay? All right, so this one's got 4 different pictures. So are y'all picking A, B, C, or D? Looks like you got an odd degree of 3, and you got a -1 in the front. Oh, that's pretty quick. Let's see. So you're saying B downhill, and that's it, right? Downhill left to right. So that would have to definitely be B. So y'all would check that and move on. All right, so let me make these a little larger. Now, if you notice, most of these got distinct different pictures. You just got to be careful for the one like I did where they both were sort of matching. All right, y'all, A, B, C, or D. So you got an even coefficient, an even degree of 4 and a +1 sitting in front. Yeah, B has that little hump in the middle, but remember, all we're worried about is what's the graph doing out on them end edges, and both ends are going up on that one. So that would be definitely a B. So see what's happening. Remember, it can turn 3 times. Since that's an x to the 4th, this one turns 3 times. It almost makes sort of like a W shape. All right, so check that, y'all. We're moving on. All right, so let me write this one down and show you how you would do it. So this has a h of x equals x times x minus 4 times x plus 5 times x minus 5. So I'll show you on paper what I do to this one, and then we'll pick our graph. So this one's already factored, but what we want to know is the degree. So we don't know the degree. So to find the degree, you take all these x's and multiply all the x's. So that's a positive x times a positive x times a positive x times a positive x. Now, we don't have to worry about the numbers because the degree is always off of the leading term, and you're going to get that by multiplying all your x's together. Well, y'all, all these x's together give me a positive x to the 4th. So remember, that's an even degree and a positive lead coefficient. So when you go back to your graph, A looks like it's going uphill, left to right. So let me zoom these in a little. And they're hard to tell sometimes. But if you notice, A goes uphill, left to right. B looks like both ends are going up. C looks like both the ends are going down. And then finally, D has a lot of turns, but it's going uphill from left to right. So since we had a degree of 4, which is even, and a positive lead coefficient, we would pick B on that one because both these ends are going up, okay? So they're a little trickier when you got all these extra lines on there, okay? All right, so I'll write this one down. G of x equals a negative x times x minus 1 squared times x plus 3 squared. So y'all, on this one, I'm wanting to find my degree again. Now remember, since you got exponents on this one, you got to treat this like a negative x times x minus 1, x minus 1. So that 2 multiplicity tells you to write that one twice. Same thing with the last one. You got an x plus 3 times the x plus 3 because of that multiplicity 2. So to find the degree again, I'm going to multiply all these x's. So that's a negative x times the x times the x times the x times the x. So notice that's a negative in here. So this one's going to give me a negative x, and I had 1, 2, 3, 4, 5 x's. So multiply all the x's together again to get the degree. So this one will have a degree 5, which is odd, and a negative lead coefficient. So we would go back to that. So let's zoom these in. And these ones are a little easier to read than the one I just had for problem 9. So y'all knowing that I got an odd degree, a negative lead coefficient, would y'all go with A, B, C, or D? So here's another case where I got 2 graphs that look really similar, right? So let's zoom these in just a little because those are both going downhill. So what we want to look at on this one is those multiplicities. So let's see. We got negative 3, 0, and 1. What's this one? Oh, so y'all, I see what it is. Look at A. A has this going at negative 3. They got that from the x plus 3 factor. Over here, it's at 1 because of the x minus 1 factor. So the zeros would be the negative 3, 0, and 1. But notice on B, they got the 0 at negative 1. But remember, that x minus 1 factor won't give me a 0 at negative 1. It'll give me a 0 at positive 1. So you better go with A on that one, okay? Because remember, your zeros would be 0, 1, and negative 3. So that's where this thing has to touch those x-axis at, okay? All right, y'all see what's got next. So let me make these larger. All right, so if you want to figure out the degree, you would have x plus 2 twice, x minus 1 4 times. So that's going to give you a total of 6 x's. So that'll be an x to the 6. All the x's were positive. So we're going to have a degree 6 with a positive lead coefficient. So y'all, that would be both ends going up. So we're really going to have to zoom in on this. So since that's an x plus 2, that tells me it should hit it at negative 2. And that x minus 1 tells me it should hit it positive 1. So we need the one that touches it at -2 and 1. So A, if you look, touches at -2 and 1. If you look at B, it's touching at -1 and 2. So they're looking at these x-intercepts on these. So for this one, we would go with A because it's touching at that 0 and -2, and it's touching down here at the 0 and 1. Okay, like I said, they got them opposite on B, okay? So go with A because you're looking at your zeros. All right, so let me zoom these in. So now it's not factored like that. So they're a little trickier when they're factored. So 10x to the third minus 6x squared minus a 90x plus 54. You got an odd degree, positive lead coefficient, so it should go uphill, left to right. But notice it's got a y-intercept. On this one, we would look at the y-intercept of 54. A is going right through the 0, right through the origin. B, if you zoom that up, remember this is going by, looks like 50s or so. So that first one is hitting that right around that 50 mark. So I'm going to say that's probably 54 because it looks like it's just a little above the line. So remember, on this one, I would go with the 54 on the y-axis, going uphill, left to right. So y'all, that's the trick on these. Look at your end behavior. And if you got two graphs that match, if it's factored, look at the zeros where it's supposed to be touching it on the x-axis. If it's not factored, then look at the y-intercept that they're giving you to see where it's crossing the y-axis. So they just want y'all to sort of get used to relating those x and y intercepts, okay? All right, y'all, so we'll get into doing more fun stuff now. So 8.3 deals with polynomial division. And the method of division we're going to learn is what we call synthetic division. So y'all, we use this in place of long division. It's easier to keep up with. And I can use synthetic division to find three things in this class. The first thing I can use synthetic division for is to find the quotient and remainder. So I can find the quotient and remainder doing polynomial division. Second thing I can use it for is to find function values. So function values like f of 5, f of 2, and so on. Now here's the thing about function values. When using synthetic division, the function value is equal to the remainder. So whatever our remainder is when we do synthetic division to find function values, that equals the function value, okay? The third thing I'll use it for is to determine if a number is a zero. So here's the thing, when you're doing synthetic division, if a number is a 0, the remainder must be 0. Because remember, that's what the function value is. If you're doing function values and you get 0 for that answer, then that means that that number was a 0 of it. Okay, so you're really focusing on these remainders to get your function values, or if the remainder is 0, to find the zeros, okay? All right, y'all, so let me find one of my problems real quick. So this first problem is what you're going to see in support. And on this problem, they want us to find the quotient and remainder. Now I'm going to write my steps over here as I work this problem out to teach you about this synthetic division. So our problem is going to be, let's see, 3x to the 4th minus 8x squared minus 16. And we're going to divide that by x minus 2. So your steps for synthetic division. Your first step, write the coefficients of the polynomial. Also, when you're writing these coefficients of the polynomial, you have to use zeros for any missing terms. So what do I mean by that? Notice over here, you got a 3x4 minus 8x squared minus 16. You're missing the x to the 3rd term, because remember, that should go next. And then after the x squared term, you're missing the x term. So remember, these should go x4, x3, x2, x, and then my number. Now, another trick, if you take the degree and you add 1, that tells you how many numbers you need when you write your coefficient. So I would take 4 plus 1, that'd give me 5. That means I need 5 numbers. So I would write my 3 for the x4 term, 0 for the x to the 3rd. So I'll just write where I'm getting these at. -8 was my x squared term. There's not an x term, so I'm going to put a 0 since there's not an x term. And then my number at the end is my -16. So we call that the constant term. So notice 4 plus 1 is 5. I have 5 numbers. So you got your 5 numbers. Now over here, we draw a little box, and that's where we're going to put what we call C. So put C into the little box. Now here's a trick. If given in the form of x minus c in parentheses, then c is opposite in sign. So if I was doing it for find function values, I'd say find f of 5. The 5 would stay the same sign. But since my c is in factor form, if the c is in factor form and negative, then you're going to change the sign and use a +2. And y'all, you're only going to change the sign when it's in factor form, okay? All right, next we're going to draw a box. So I usually draw my box under my numbers. And the last section under the -16, I box that in. So draw the box. All right, so this is getting us ready for synthetic division. We got our 5 coefficients, our C. So here's the trick. The first number or the first coefficient always comes straight down into the box. So bring first number down into the box. So now what I need to do is start getting these numbers under these coefficients. So to get the first number under the 0, to get that number, you take the number down here and multiply by C. So I would do 3 times 2 and get 6. The 6 goes in the second column under the 0. So what I did, I multiply the number times C and put into next column. All right, so let me pull this down just a bit. All right, add the column. So we're entering columns like this, you add them together and put that answer in the box. So let's see, 0 plus 6 is 6. That answer is now in the box. At that point, repeat until done. So to get the next column, the number under the -8, I take that 6 I just brought down, multiply by 2. So 6 times 2 will give you 12. Now I got a 12 in the column with the -8. I'm going to add them together. So 12 and -8 will give me a +4. So y'all, let me ask y'all this. What number do y'all think I'm about to put under the 0? So definitely I'm going to put an 8 there because 4 times 2 is 8. All right, we're going to add that 0 and 8 to that column and get an 8. So the next question, what number am I about to put under that -16? Good job. That's going to be a 16 because 8 times 2 is 16. And y'all, this -16 and 16 give me a 0. This little box here, that is our remainder. The remainder is always in the last box. So since I had a 0 remainder, technically, that means that 2 is a 0 because its remainder was 0. Now, they wasn't asking us on that. They was asking us for what? The quotient and remainder. So the quotient. Y'all, these are the coefficients of the quotient right here, these first 4 numbers. The quotient always starts 1 degree less than the original. So since I started with an x4 in the original problem, this is now the x3 term, x squared term, x term, and a constant. So this would give me 3x to the third plus 6x squared plus 4x plus the 8. So the quotient is given by those 4 numbers on this one. And remember, it always starts 1 degree less than the original. So I'll write that. starts 1 degree less than the original. So you'll have the quotient, and then it'll probably say remainder. And on this one, our remainder was 0. So there's a factor theorem also that tells you when you get a 0 remainder from division, that means x minus 2 is also a factor of that polynomial. So y'all, let me try one more of these with you, and then we'll look at the college algebra stuff. So this will be another support. I think supporting had to do 3 of these. And in college algebra was like 5 or so. All right, so another one to do. They're going to give me, oh, let's see what I want. I'm going to do this one. C to the third minus 8c squared plus 32c minus 11. We're going to divide that by c minus 4. So first, we're going to write our coefficients. So think about this. It's a degree 3. So if you add 1, that gives you 4. So we need 4 numbers. And y'all, this has all 4 numbers because it has the C3 term, C squared, C, and then your constant term. So your numbers for this would be a 1, -8, 32, -11. I'm going to draw my little box here. And then my little box for my C. So let me ask y'all this. What would I put in there for my C on this one? So good job. It's definitely going to be 4. So factored form, they gave me -4. I'm going to change that to a +4. All right, y'all. So here we go. The first number always comes straight down into the box. All right, so what goes under the -8? Okay, so that'd be 4 because 1 times 4 is 4. So any number down here multiplies to get that next column, okay? All right, y'all, -8 and 4 gives me a -4. So now we're going to take -4, multiply by 4, that's going to give us a -16. Add the column, 32 and -16 will leave us a 16. 16 times 4 gives me 64 for my last column. So this one looks like it's actually going to have a remainder. So 64 and -11. Oh, let's see, that's going to give me what, a 53 for a remainder. The first 3 numbers are my quotient. 53 is my remainder. But remember, these start 1 degree less. So that's going to be 1c squared minus 4c plus my 16. And it has a remainder equal to 53. So what are y'all asking me? What's not negative? The remainder? Oh, remember, I'm adding those. Remember, I'm adding those, and that's a -11 plus 64. Okay, there you go. Okay, so support will have you, like I said, support will have you finding quotients and remainders. College algebra, we're mainly going to look at function values and zeros. So here starts the college algebra homework. They want us to use synthetic division to find f of 1, f of a -5, and f of 6. The polynomial they're giving us is f of x equals x to the third minus 12x squared plus 41x minus 30. So for this section, remember, function values are equal to the remainder. So whatever remainder I get in the box will be the answer to these problems. So y'all, looks like I got to do synthetic 3 times with 3 different C's here. So let me write my coefficients. I need 4 numbers because 3 plus 1 gives me 4. So I got a 1, -12, 41, -30. So notice nothing was missing on this one. So I'm gonna draw my little box. So my C does not change signs since they're not in factored form. They want me to find f of 1. That means my C will be a 1 for this one. Now this one, we don't care about the coefficients on this problem. All we're looking for is that remainder. So y'all, here we go. Bring the first number down. This number multiplies by C, so 1 times 1 is 1. That goes in my next column. -12 plus 1 gives me a -11. Multiply that by the 1 gives me a -11. 41 and -11 give me 30. And y'all look at this, 30 times 1 is 30, which gives me a remainder of 0. So that means f of 1 equals 0. So 1 is actually a 0 of this polynomial because of that remainder. All right, y'all, so let's try this one. We got a -5 here. We're using the same numbers, 1, -12, 41, -30. All righty, so here we go. Bring the 1 down. Then you're going to do 1 times -5 is -5. -12 plus a -5 is a -17. -17 times -5 is a +85. Right, let's add them together. That's going to give me what? A 6. That's going to be what? 126. 126 times 5 gives me a -630. And y'all, finally, -630 and -30 give me a -660. So that means f of -5 equals -660. That's the same answer you would get if you put a -5 in for all 3 of them x's and did order of operations. All right, y'all. So I want y'all to figure out f of 6, and we'll see if y'all are correct. We'll give y'all a second, play with that one and see what y'all get, okay? All right, so any of y'all actually working, man? All righty, I'm not seeing no chats. All right, so y'all gonna make me do this one, right? So, oh, so I got an f of 6 equals 0. So let's see if she's right on that. Bring the 1 down. 1 times 6 is 6. Negative 12 plus 6 is negative 6. Negative 6 times 6 is negative 36. 41 and negative 36 is a 5. Oh, look at that. 5 times 6 is 30. Negative 30 and 30 give me a big 0. So good job. F of 6 is definitely equal to 0. So look like a few of y'all don't mind this stuff. All righty, so let's try this. They want me to use synthetic division to determine if negative 5 and 2 are zeros of f of x equals 3x to the third plus 10x squared minus 19x plus 30. So remember, if there are zeros, then the remainder has to be 0. And let's see, that's 3. So if I add 1, that tells me I need 4 numbers, 3, 10, negative 19, and 30. So no missing terms. So I'm going to write out my coefficients, 3, 10, negative 19, and 30. Draw my box. And then C. So since they're asking us about negative 5 and 2, we do not change the signs. Okay, so only change that sign if it's in the x minus 5 or x plus 5 form. All right, so these are the yes or no questions. So let's see if negative 5 is a 0. So first we bring down our 3. 3 times -5 is -15. That goes in the next column. And see, that's how come you bring that 3 down. There's nothing here to multiply and get a number in that column. So you bring that number down, then you start the multiplying. All right, 10 and -15 give you a -5. -5 times -5 is 25. -19 and 25 is going to give me a 6. And here we go. 6 times -5 is -30, which gives me a 0 remainder. So this one is definitely yes. Then you're going to do the same thing on 2. You got the same coefficients. So I'm going to give y'all a few minutes to tell me whether or not that 2 is a 0 of that polynomial. All right, so I'm seeing a no on that. And so let's see if we're right. So the 3 came down. 3 times 2 was 6. 10 and 6 gave us 16. 16 times 2 was 32. Let's see, what's that? 32 and 19. That's going to give you 13. 13 times 2 was 26. Oh, good job. You got the remainder and everything. That had a remainder of 56. So good job. That is definitely a no. Now, here's a trick on the question, on that question when you do it in homework. Go in order that they give them to you, because it's going to be yes, no, yes, yes, no, yes, or no, no, okay? All right, so I wanted to do one more of these. So like I said, the college algebra is just going to ask you to find those function values and determine if they're zeros. But y'all, this one was sort of tricky. Is 1/2 a 0 of f of x equals x to the third plus 1/2 x squared plus 5/2 x minus 3/2. All right, so we're looking at 1/2 this time. So let's see, I need 3 plus 1 is 4 numbers. So I got a 1, 1/2, 5/2, -3/2. So we got all of our numbers. So bring down your 1, 1/2, 5/2, and a -3/2. See, they're giving me, that's going to be the 1/2. All right, so we got to love fractions. So here we go. Bring down the first number, 1. Now we'll say this. This problem's not as bad because they all do have a common denominator, okay? If those denominators were different, then it'd be a little trickier. But watch, this ain't bad. 1 times 1/2 is 1/2. Well, remember, when you add fractions, add the numbers on top, put them over that denominator. So 1 plus 1 gives me 2 over 2. But remember, 2 over 2 will reduce to a 1. So 1/2 plus 1/2 gives me 1. So now I multiply. 1 times 1/2 Gives me 1/2 again. So let's add the top. 5 and 1 is 6 over 2. Well, 6 over 2 will reduce to a 3. So just remember, adding fractions, add those tops, put them over that denominator. And then if you got 2, divide to be done. All right, so now we got 3 times 1/2. Well, what I do to that is I just put a 1 under the 3, multiply straight across. 3 times 1 is 3. 1 times 2 is 2. So 3 times 1/2 gave me a positive 3/2. And y'all look at that. Negative 3/2, positive 3/2 gives me a 0 remainder. So the answer to that question would be yes. All right, so that's probably the trickiest one on your college algebra. So let's do one more. Let me see. I'm gonna do one more like the support. So a to the third minus 9a squared plus 9 divided by a minus 4. All right, so y'all tell me my coefficients that I would write out for this one. Oh, good job. 1, -9, 0, and 9. Good job, because you got to have a 0 for the A term. So what will C be? So since that's -4 and it's in factored form, you would definitely put a 4 there. Good job. Now remember, this is going to want the quotient and remainder. So let's get that quotient and remainder. So we're going to bring the 1 down. 1 times 4 is 4. -9 and 4 give me a -5. -5 times 4 is a -20. 0 and -20 give us a -20. And then finally, y'all, -20 times 4 is a -80. So let's see, 9 and -80 is going to give us what, a remainder of a -71. But y'all remember, quotient has to start out 1 degree less. So this would be a 1x squared minus 5x minus 20. Now I'm going to show you another way that they write the remainder. So for this one, since I got -71 for my remainder, they do plus -71 over the a minus 4. So, my bad. A squared minus 5a minus 20 plus the -71 over a minus 4. You actually got to write it in terms of the a. Good job. See, I get looking at my numbers and I don't even look at my variables, right? So yeah, and I think on this one, MATLAB actually has the 4 answers. So look at the one that has your coefficients and your remainder of -71, okay? All right, y'all, let's see. Any questions on this? I sort of like doing this synthetic division. It's not bad. All right, so any questions? So do y'all got any questions on anything that's bugging y'all in this material or prior material? So for tonight, you just want to do your 8.2 and 8.3. Next class, we're only going to do one section, and that'll be 8.4, okay? So I think the support for 8.2 didn't have support. You just had to do the problems we did on the computer while ago. 8.3, the support has 3 problems, sort of like these ones we were doing. And then the college algebra part has like 5 problems. Yeah. So that'll do it on those. Okay, so I'll stop our recording.